We are going to be doing today a conformational analysis of cycloalkanes. For example, you can have this cyclopentane, or you can have cyclohexane. And as you see here, the figures are flat, just a pentagon and a hexagon. But if you did take, for example, the cyclohexane, and I'm going to hold the model and think as if this is flat, right? Now, looking at the model, considering this flat, as you see this here, now looking at that in perspective as we did in the Newman, if this is all flat, notice this carbon is eclipsing the other carbon in the back. We have a lot of those. And here we have this, and this one in the front, also eclipsing on this side. This is eclipsing this. So we have a lot of these interactions that are present in the eclipsing conformation when we did Newman. This, in fact, is a Newman, but of a chair. Now, these, to avoid this type of interaction, actually, cyclohexane is not flat. So it will adopt different conformation. And the more stable conformations are called chairs. And that chair, notice that I put the side a little bit up. So say where you would sit, this is your back, where you sit, and this is where your feet go. So that's one chair. And we're going to be analyzing the conformations of this chair and then the flip chair. And so this conformation changes by rotating bond, and we can go say a semi-chair, this side flat, this is higher in energy. And then because of eclipsing interactions, right here we have another conformation that we call a boat. And notice that this side that was down, I move it and put it up, right? And now this side that I have the boat, and from this, I'm gonna take this one and put it down. Now this is what we call the flip chair. This is the other chair. So this is where you sit, your back, your feet. So we're going to be doing this. Another thing that we want to analyze, let's look at the Newman projection of this chair. Notice this as we have here in the model. Now we no longer have those eclipsing interactions. This looks like the stagger conformation of the Newman. Notice this carbon here as well, eclipsing the other. This looks like the stagger. So this conformation, when we have the chair, we have less eclipsing interactions, more the looking like the stagger, as we see here, the Newman projection of that. See, holding the Newman right now, and this is now like tilting it. You see the chair projection. Now I'm gonna show you how to draw that. So when we have a chair, say that this is where you're sitting, this is where your feet goes, this is where your back goes. So that's my chair. So we have two types of position in the chair. The positions that are actually, say, vertical lines sticking up and down are called axial. So I'm going to say one up, one down, one up, down, up, down. Now, other positions in this chair, again, let me go back to the model. These are the axials, sticking here vertical relative to this plane. And there are also other positions that are actually kind of tilted respect to that. And where you have the axial up, so this one here, you have an equatorial position. So the other positions are called equatorial. And if this is up, this is slightly down. And so now we're going to be drawing that. So up, the equatorial, and I'm going to write so equatorial position. So also alternate down, up, down, up, down, up. So this is one of the chair. I'm going to redraw it again to show you how to do the axial and equatorial. So let's do just one type of position. Again, we're going to draw, say that we draw the central part, then we draw this part, and now let's do axial position, so vertical lines. So up, down, up, down, up, down. And same thing, we're going to be doing the same chair, but now just the equatorial positions. So this is my chair. And now let's do the equatorial. If this is up, equatorial will be slightly down. So down, up, down, up, down, up. Combining these two, we have this picture showing all the axial and equatorial positions. Now that we know this, we're going to flip the chair and study different conformations in substituted cyclohexane molecules.